So here are our last problems we're going to look at for translational systems. And so let's see what we have here. I have a mass, all right? These two are in parallel, so as we've seen that before. But here we have a point again where we have some elements in series with another element. So we'll have to use the trick we learned just a little bit ago to do this one. So we're going to have to do a mass equation for this point and one for this point. We'll start with M2. So what would we do? We're going to hold this spot still. We're going to move M2 in a positive direction. And what will it feel? Well, there's this force taking it positively. Then we'll have K2, X2 will oppose it, and B2, X2 dot. That'll be going both back this way. All right. And then if we hold M2 still and move mass 1, which is 0, right here, as I move this forward, that will push M2 forward by K2, X1. And we have that right here. K2, X1 moves it forward, minus K2, X2 opposing, minus B2, X2 dot opposing plus F. One done. All right, now we have to do a second equation here for what's happening right here. So we'll do the same game. All right, if we move M2 in a positive direction, what does this virtual mass feel? It feels K2, X2 going positive. That's it. That's all there is. All this other stuff, it doesn't feel. It only feels what goes through this spring. To finish, so then we hold M2 still and I move X1 in a positive direction. What does it feel? Minus K1, X1, minus B1, X1 dot, minus K2, X1, minus K2. Did I get that wrong? Nope. Oh, here I am. This is the wrong spot. Excuse me. Minus K2, X1, minus B1, X1 dot. Okay. And minus K1, X1. They're all here. And then if one wants, you can simply rework the numbers. So here I rework this thing and I put the X1s on one side and the X2 on the other. You can make a transfer function and substitute in for the X1 here, and you would have everything in terms of X2. So there we go. Straightforward. One more. We're going to do this. Now notice what I'm saying here. We're measuring everything from the static equilibrium position. That means stuff is hanging. So at the start, we go and say, okay, let all these masses just hang, and we're going to measure from that point. So let's look. The first mass is held up by a spring from the ceiling, and it's holding up another mass, so these two springs, and it's got friction against some guide over here. So we'll have that. This mass 3, is measured again from the static equilibrium position. It's held up by this spring and this damper, and it's getting pushed up actually in a negative direction by this force. This mass is held up from the ceiling by this spring, and it is then through these two elements supporting this mass. We have 3 masses. We don't have anything in series, so that we'd have to treat like a mass. So we just have mass 1, 2, 3. And so let's start with mass 1. We move mass 1 in a positive direction, holding mass 3 constant. Okay. As this goes this way, we have a minus K1, X1, a minus K2, X1, and a minus B1, X1 dot. And here they are. K1, X1, K2, X1, negative, minus B1, X1 dot. If I hold that still, the only mass connected to it is 3. I pulled that mass down, and that will want to pull M1 down. So that'll be M for M. When I move M3, M1 will feel K2, X3 coming down. Positive. All right. So now I go to 2. Mass 2. What do we have? I hold M3 still, I move M2 down. What does it feel? It feels K3, X2 going up, B2, X2 dot going up, K4, X2 dot going up. And I have that K4, X2, negative going up, B2 x2 dot going up, and minus K3 x2 going up. All right, now I hold this still, move M3. What does this feel? It feels through this damper plus B2 x3 dot and plus K4 x3. And there's that equation, all done. Now that takes us to mass 3. So let's do it the same way. I'm going to hold M1 and M2 still, and then I'm going to move M3 in a positive direction. What does it feel? It feels K2x3 going back up. There it is. K2. Why did I write K4? There is no K4. This is K2. This is a mistake. Okay. So I move M3 and K2 x3 goes up. There we go. I have B2 x3 dot going up. It's negative. K4. This was the mistake. K4 was right. K3 was wrong. This is perhaps the hardest part of these problems, keeping all your subscripts straight. So let me start over. I hold M1 and M2 still. I move M3 down. As I move M3 down, I get a K2 x3 going up. K2 x3. There we go. B2 x3 dot going up. K4 x3 going up. So I'm done moving this, and I have a force going up, so that's minus F. That's everything M3 feels from just moving as I move M3. Now I hold M3 still, and I move one mass. I'll move M1 and say, what does M3 feel? Well, it feels K2 x1. And we have K2 x1 there. So now I hold these two still. I move M2 and say, what does M3 feel? It feels B2 x2 dot going down, positive direction, and then K4 x2 going down. And those are all the equations. We got it. So that finishes translational systems. Next time we're going to start rotational systems, and they're conceptually the same, because picture when you have rotational systems, we can have multiple inertias instead of masses, and we're just going to take turns twisting the various inertias and say, what do the other inertias feel? It's that simple. So pretty much the same stuff, just slightly changed how it's oriented. We'll begin that next time. Bye for now.